T-minus 10 seconds. 9, 8, 7. Go for main engine start. 3 main engines up and burning. 3, 2, 1, 0, and liftoff of the Space Shuttle Discovery and the Upper Atmosphere Research Satellite, opening a new era studying the Earth's environment from space.
Roger, roll, Discovery.
Mission Control Houston now controlling the flight of Discovery.
AFS Dialogue presents a presentation by Jack Kasher. Dr. Kasher is a physicist at the University of Nebraska at Omaha. He is currently analyzing video footage of anomalous objects taken during shuttle mission STS-48, which NASA scientists had concluded to be ice particles dislodged from the orbiting shuttle.
Well, what I'm going to tell you is the result of my analysis as a physicist and a scientist, just taking the data and seeing where it goes. And the bottom line of my investigation is I started out my investigation assuming that they were ice particles and trying along the way to prove that they were ice particles. And I found out that at least if you take the data that I've got and the analysis that I've gotten, that I've done of it, that's a completely untenable position. And after that, there aren't many options. Meteors, absolutely not. They don't change direction. And space junk and satellites don't change direction. There are no other options. These are objects that are clearly at times above the air glow, and so they're maneuvering, and they are in outer space. Therefore, they're spacecraft. I don't see any other interpretation that you can have. They are some kind of spacecraft.
We're here with Dr. John Kasher, who's a professor of physics.
That's right.
At University of Nebraska, Omaha. And you've been doing some research. Well, you've been involved in UFO research for I'm not sure how long.
Actually, I first got into it in the early 1970s. I was asked to be a consultant for the Mutual UFO Network in Nebraska, and so I agreed to that. And then I received calls over the years when people had had sightings. The State Patrol would refer people to me, and Offutt Air Force Base would also refer people to me. So I've been in it for a long time, and then I got very intensely interested in it about 1987. I had kind of a, I don't know, rebirth or something like that. I started reading everything I could get my hands on and became a lot more involved with MUFON and going to conferences and meeting people and doing research. And as a result of that, I've been gathering information and giving talks both locally and nationally on UFOs too.
And your background is in physics?
Yeah, I have a doctorate in physics. I got that from Boston College. I studied relativistic particles, electric charges, and then I also worked at Lawrence Livermore National Laboratory from 1975 through 1992. I worked there in the summer, and then I did consulting for them during the year too while I was teaching here. I worked on electromagnetic theory mostly and several different problems. Toward the end I was working on the Star Wars defense program. I was studying microwave laser penetrating the atmosphere and the effect it might have. And it was bordering, some of the information was classified, so I can't talk about that, but some of it's general knowledge too. And I saw that the Star Wars program was losing its funding, and so I started looking around, seeing the handwriting on the wall, and ended up hooking up with NASA in the summer of 1991, and I've been doing research for them ever since, and I hope to continue that indefinitely. They're a very good group, and we're involved in a very good research project studying the surface of the sun.
Oh, really?
Yeah.
Studying the surface, meaning?
Meaning we study,
there's
some large features called supergranules that seem to grow and then die and move across the surface, and it's important to understand them because that may lead to information about sunspots and then solar flares, and then that reflects back on communication systems here on the Earth. So it could be very, very important stuff.
Okay. You've also done some examination of the NASA footage from the STS-48.
That's right, yeah.
Why did they call it 48? Is that the 48th mission? No.
Well, I'm not really totally sure. It has to be maybe the 48th mission, but they're not sequential, and so It's a little confusing to me. I'm sure there's a good reason for it.
Yeah.
Maybe it's the one that they planned and they got out of order or something.
But that was the footage, obviously, that had the ice particles that look like
Quote,
controlled
unquote.
craft.
Yeah,
Yeah.
that's right. Yeah, the anomalous objects, I guess we'll call them.
Can you explain how does that footage come into public domain? I mean, how, what's the origins of the footage?
How do we get it, in
Yeah.
other words? Well, the history goes this way. Don Ratch, who's a UFO investigator in Maryland and is associated with Dundalk Community College out there, had some kind of a project, and he was recording the entire shuttle flight, or at least large segments of that particular one. That was Space Shuttle Discovery.
Mm-hmm.
And so he was recording off NASA's NASA Select channel, which is a national cable television channel. Some areas get it and some don't, but it's one of those national things. Mm. And that's out in the public domain, so he just taped it right off that. And so it's not a mysterious thing. It was there and he grabbed it. And when he found out about it, this is the way my understanding of it goes, then he contacted Vince DiPietro, who works at Goddard Space Flight Center. He's an engineer there. And Vince went in and he also got his copy of the tape from NASA's files. And then all the publicity and so on. This was, I guess about late October or sometime in October of 1991. And then we got the tape shortly after that. Harry Jordan and I did. And so we analyzed it and more or less kept it quiet and shared it with a few people. And then the following spring, Don Ecker from UFO Magazine broke it on hard copy, broke the story.
And it was on Larry King.
It was on Larry King. He debated James Oberg on Larry King. And then in the following September, which was last September, Harry Jordan and I and Oberg and David Froning, I think, another physicist, were on the sighting show, and we discussed it there.
Are they intelligently controlled objects operating?
Well, what I'm going to tell you is the result of my analysis as a physicist and a scientist, just taking the data and seeing where it goes. And the bottom line of my investigation is I started out my investigation assuming that they were ice particles and trying along the way to prove that they were ice particles. And I found out that at least if you take the data that I've got and the analysis that I've gotten, that I've done of it, that's a completely untenable position. I have 4 separate proofs that to me are conclusive in showing that the objects are not ice particles. And so I think it's really tough to defend that position when you get down to the nitty-gritty and analyze the thing scientifically with calculations. You can certainly kind of speak generally and qualitatively about what they look like, and maybe they're ice particles and there have been ice particles in the past, etc. But once you start really putting the numbers down, there's just no way that I can really say myself. If I were a NASA scientist given the job proving that these are ice particles, I have to go to my superiors and say there's just absolutely no way I failed. I can't do it. And the evidence that I have very strongly indicates that they can't be ice particles.
So if they're not ice particles, what would be the next logical conclusion?
There aren't many options. Somebody has suggested that they're little tiny flecks. I think Bob Lazar has mentioned, he's a physicist too, he's suggested that they're little tiny flecks around the camera.
Yeah, I think he said that,
Yeah, he did. That is not acceptable because the camera was focused at infinity, and any little specks would just be invisible. And you can tell that's true because toward the end of the segment, the camera pans down and looks at the side of the cargo bay, and you can see it's grossly out of focus. Then it focuses and then turns toward the front. So it was focused at infinity, so any little particles near the camera don't work. Ice particles don't work. And after that, there aren't many options. Meteors, absolutely not. They don't change direction. And space junk, and satellites don't change direction. There are no other options. These are objects that are clearly at times above the air glow. And
are they
maneuvering.
out of the atmosphere?
Yes.
They're operating above the atmosphere.
Some of them have to be, because you can see them against the dark sky, and you can see the Earth and the air glow on the horizon below that. And so they're maneuvering, and they are in outer space. Therefore, they're spacecraft. I don't see any other interpretation that you can have. They are some kind of spacecraft.
So that in space, they wouldn't be affected by air current or a blast from the rocket necessarily?
Well,
from the shuttle?
Ice particles could be. See, they would be close, and they would be in a vacuum around the shuttle, but when the thrusters would fire, then the exhaust would come up and push them. That's the scenario that 4 NASA scientists are suggesting. And so I mean, that is a feasible explanation if the analysis holds up. If they are away from the shuttle and above the atmosphere, then there's no way they can maneuver unless there's some kind of a spacecraft that's being directed somehow, either by somebody inside or remotely controlled. We can't tell what that is, but once you prove they're not ice particles, then there aren't many options. They've got to be spacecraft.
Let me ask you this. We're sitting in the science department at the University of Omaha, and you've got UFO books on your shelves.
That's right.
I'm just wondering, how does how does the staff respond to your interest in ufology?
Well, in general, it's mixed, but overall, very positive.
Is it?
Yeah,
okay.
It really is. I've gotten some support from my department chair. He helped arrange my schedule several years ago, 1989, I guess, so that I could go to Germany, to Frankfurt for a UFO conference. He didn't supply department funds. He didn't feel as though he was justified in doing that. But there's a lot more involved in that. Some of my colleagues look over my shoulder very curiously, wondering what's going on, and I get a lot of good-natured kidding. Not really anything negative so much.
Yeah.
Also, the subject of UFOs is part of the subject matter of some courses that I teach.
Oh, good.
So it's got academic credibility in the community.
Yeah.
We teach a course, I teach a course with Dr. Dale Stover from Philosophy and Religion on supernatural phenomena, and we spend 5 weeks of the semester just on UFOs.
Oh, really?
Yeah, and then I also teach...
Going through a historical look at it, or?
There's some history involved, and then there's a lot of separate incidents that we study in some detail and try to look at the whole picture. And at least as far as I'm concerned, the evidence is really overwhelming that extraterrestrials are here. It's hard, after you see 5 weeks of that material, it's really hard not to have that opinion, I think.
Yeah. Well, being a physicist, too, you must be interested in the drive systems.
Yeah, that's right.
Are you assuming that they're, and there's a book on gravitation, are you assuming they're, I mean, they're obviously some type of an anti-gravity device?
I think that's a reasonable...
Electromagnetic in nature?
Yeah, well, maybe not so much electromagnetic. And again, we're speculating. We don't really know, but an anti-gravity device would work very well. I think Bob Lazar has suggested, and incidentally, most of his science really holds up. He suggested that there's an anti-gravity or intense gravitational wave generator on the craft.
115.
And element 115 helps make that. And then it warps space so much that you can jump from here to there without having to go through the thousands or tens of light years in between. And
well, the way he explains it is it actually grabs a point, draws that point to the craft.
Yeah.
And then
you jump over.
Yeah, it's a hard concept to...
Well, it's way beyond anything we can even dream of doing now, but it's scientifically sound. It does work.
So you're involved with Mutual UFO Network, Midwest?
Well, I'm the state director
Nebraska?
for Nebraska, yeah.
Okay.
Each state has a director, and I'm the Nebraska state director. And MUFON's a really good organization. They've got more than 4,300 members worldwide, and I don't know what the current numbers are, but it's roughly 200 people with doctorates who are consultants in different areas, and more than 200 who have master's degrees.
And every month they're signing more up.
That's right, yeah.
In record numbers.
And these are serious people that are interested in bringing their expertise to the question and not really just sitting with your armchair interpretations of things.
Yeah. So what you're saying is that the whole field is getting a lot of serious interest by the academic community, which is a positive. It's got to be
That's
positive.
right. Yeah, you get people like Dr. Dave Jacobs and Dr. John Mack and others that both academically and professionally are getting more involved in this. And Dr. Pritchard, who's a physicist at MIT, had a conference last summer on it. So respectable academicians and professionals are becoming involved in this, and I think that's a really good thing because something's going on. And
people need that to...
we need to know what's going on.
Yeah. We are dependent on our scientists.
That's right, yeah. And Bob Bigelow is helping a lot with his support for the Roper Foundation, and he also has other things. He's helping with the Triad conferences that are being put around the country. I was telling you earlier that I spoke at Seattle on July 17th at the first Triad conference, and there will be more of those.
What is Triad, just briefly?
It's an organization. I'm not sure where the name comes from, but their purpose is to have speakers go to different areas of the country and maybe even internationally and tell about their areas of research in the UFO question and maybe other aspects of the paranormal too, just to educate people and let them know about what's happening.
So let's talk just briefly about Nebraska. What's occurring in Nebraska? What types of reports do you receive? What type of activity is occurring?
Well, the day-to-day business, summer's been a little bit slow. This summer has been. But I have received calls from people that have seen saucers and have seen lights and the whole gamut. And sometimes I investigate, sometimes I punt and have other people investigate too. There is activity, and there is activity in this area. The abduction part of it is I don't know what the right word is. Staggering is a good adjective to use. We have an abduction support group here in Omaha that has 54 members, and it's growing. They meet every month to provide support for each other. We really need mental health professionals to help these people, like Dr. Mack is doing.
And John Carpenter, yeah.
Yeah, and I've been asked to go out to their meetings and kind of help them and lead the discussion, but I'm a physicist. I'm not a psychologist or psychiatrist. We need these people to step forward. It's a grave question, and it won't go away.
Yeah. Yeah, it is an aspect of the whole thing. I think that's probably propelling people's acceptance, really, of it, because it's occurring across such a broad spectrum.
That's right.
That you can't ignore it anymore.
Well, somebody asked John Carpenter about the Roper report in Seattle at the Triad Conference about whether he really thinks that more than 1 million people have been abducted in the United States, and his answer was the number that have been treated in this country is in the thousands now.
Yeah.
So it's not hard for him to believe that there may be more than 1 million.
Yeah, David Jacobs' comment was that survey was done on the adult population only. Didn't include children.
Over 18 in the continental United States.
He believes that the 3.7 million figure is conservative. He says it's probably up closer to 5 and 6.
That's right. Yeah.
So it just keeps kind of getting bigger and bigger, and I think we're just like learning to accept it more. You know what I mean? The
That's right. It's so staggering that when I give UFO talks, I give about 25 a year around here. I'm very careful not to say that too early in the talk because it's so bizarre, and you're just right on the edge of credibility. Blowing people away when you talk about UFOs anyway. And to bring that up, I mean, that's just unbelievable.
Yeah. Okay, let's move into your specific area of interest.
What I've been working on lately is that shuttle flight and that tape that you talked about. And we've talked about the background of it a little bit, and then I was given a copy of it, and maybe a little bit more background might be helpful. I was on the sighting show, as I mentioned, and as a result of being on the sighting show, I was contacted by people all over the country for various reasons. And one fellow, Michael Muckerheide, who is a laser physicist who runs a laser laboratory in hospital, St. Mary's Hospital in Milwaukee, called me and set me up with Professor Darrell Seeley, who is a professor of physics and chemistry at the Milwaukee School of Engineering and a laser physicist. And then he in turn set me up with a microbiology group at the University of Milwaukee, Wisconsin. You might wonder what microbiology has to do with the shuttle film, but they have access to some software that's not available commercially that they use for analyzing videotapes of little tiny creatures that swim around in Lake Michigan. And so it's perfect for these little particles because they can go frame by frame. They have a grid they put over the television set, and then they can locate the object and click on the mouse and then advance one frame, a 30th of a second, find it again and click. And so you can track where the thing goes. And so in the end you have data that you can graph and make a position time graph, and then you can, I'm not sure how technical we want to get, but we have to do a little bit of that. You can take a numerical derivative of that, and then you get a velocity time graph. And then I've been able to do something that I think is unique that really helps me get added information. You have a two-dimensional television screen, so all you really apparently see is left and right and up and down. But I've been able to extract all three motions, left and right, up and down, and in and out, by transferring from the viewing angle that you get from going from dead center to left and right. And so I've been able to figure out the three-dimensional velocities of those objects. And so I can really track where they're going, both before and after, and that has enabled me to arrive at my proofs that I have. That's very crucial to my analysis, and I can now, I have 4 proofs that to me are fairly conclusive. Each one independently is fairly conclusive that those objects simply are not ice particles.
Okay, is that something we can cover then, the 4 sort of
we can talk about them and get to whatever level of technical material that you want, and at the same time I don't think it'll be that difficult for people to follow the general gist of what's happening.
Okay.
Somewhere along the line maybe we should just take a look at the video.
Definitely.
And then I'll point out some things and then we can go from there.
Okay.
Now this is what we want to look for when we watch the video itself. There's a line along here that is actually the air glow that you might tend to mistake for the horizon, but it's actually about 40 to 60 miles above the horizon. The horizon will be just a very faint line that comes along here. Then there are several objects that are of interest that we want to watch. A couple down here really don't do too much. They come down and I've marked an X where the flash occurs, and this one just continues, this one just continues. This one pops up and floats along and then disappears, so isn't terribly significant for what we want to do. We have a slow object that drifts very slowly through, and then the flash, and it goes up and to the left. We have a fast object that comes in partway through the scene, and then at the flash it reacts by going up and to the left, as if you let your imagination wander, as if to meet this one coming up. And this is the main object, of course, that we're interested in. It appears below the horizon on this side of the Earth, so unfortunately we can't place it at the horizon. And then it moves up, and at the flash it reacts by sharply angling up to the right here. 3 seconds after it does that, a streak moves through where it had been. A second streak shortly after that moves through the area where the fast and slow had been. And then this object, which I call the second object, drifts up for a good period of time. At the flash, then reacts by moving up and to the right. So these are the things you want to watch for when we actually see the videotape. Okay, ready?
Yeah.
All right. What we're going to see now is about 3 minutes of just the shuttle picture before the event happens. And so we can kind of get a feel for how this whole thing is going to go about. You'll see some beautiful shots, beautiful lightning. That is pretty, isn't it? And some lightning and then something happening down here. And I may be able to adjust a little bit. I think we can see it well enough as we watch this. But it's real pretty. I don't know what this is down here. Looks like maybe a city or whatever. You can see the lightning flashing. This is the top of the air glow. And the horizon is right here. If you look closely, you can see it. The actual Earth's horizon is right there. You can see that star going down into the air glow. That's in the horizon now, and it will disappear when it gets to the surface of the Earth. And see, watch it. It'll go away. And you can see this flashing. We're going to watch the events as they occur, and then we will watch for another minute, and then the camera will pan down, and you'll see the side of the shuttle, and then it'll pan to the front. That's how I located where the camera was, which camera was being used. There was a little bit of a sound there.
Okay, Jeff, thanks.
Now this is going to be one of the objects that is of interest to us. We're not really quite ready yet, but we're just going to enjoy looking at the shuttle. But when it pans down, it's important to realize that you'll notice that the camera view does not, angle of view does not change. And you'll see when it gets down, you see the side of the cargo bay that it's out of focus because it was at infinity. That's important for us to know. Now this is starting to get down there, so things are going to start happening pretty soon here. There is object number 2 that comes up and over like this. So that's something we want to watch. It pops in there early on. There's another funny object down there. But you'll notice this is just kind of creeping up there. And you'll see a couple drift over here. Yeah. And here comes one. That's not going to be of interest too much to us. That's the one that was across here, and I said it goes out. But there's object number 2 again now, see? Here comes the slow object right there that I've labeled slow. And see, this one's going away. There's one of the 2 that was going down like this. Pretty soon now we're going to see the main one appear. Right up there it is, right there. It's going to go over here, there will be a flash, and it'll take off back to the right. So here it comes. They come up here, you'll see a flash. Watch down here for the flash. There's a flash, and there it goes. And there goes the streak. And here comes another streak, kind of hard to catch. We didn't see it too well. Here's object number 2. It's kind of hard to watch all of them at once. There's the fast object. I didn't even watch this one. But it came in and over. Here's the slow. It's going up like that also. And here are a couple more that I talked about that are a little bit too close over here to be able to really analyze. And after about 65 seconds, they're going to turn the camera down, and I'll point out how that works as we watch it.
Discovery Houston for JO. Morning, JO. We predict the maneuver to the supply water dump attitude will take about 15 minutes, and in order to start the dump on time, we'd like for you to do that maneuver now. We need it to prevent contamination.
There goes the camera. These 3 objects, watch them now. They don't spread at all. They'll more or less stay at the same level, which tells us the camera angle view is not changing.
You initiate the maneuver, and then when you get there, initiate the water dump.
And they're getting their way up to the top here, still the same distance apart. There's the funny little critter there.
Yeah,
You're going to get another one coming over there. And then we'll be on the cargo bay. Now watch, it's out of focus. That's important because these things could not have been little flecks. This is out of focus. And then they'll focus it. There it comes into focus. So little flecks in front of the camera don't work. Now it's going to pan over, and you'll notice the angle of view is not changing at all. And it's going to pan over, and we're going to see the front of the shuttle. See, this is how I located where the camera was. And also by how many screens it turned down, and I could figure out at what angle.
Seeing in that image, what, is that the nose right there?
No, the nose is out in front. This is the front of the cargo bay. You'll see a little better in here in just a second. It'll come out pretty well in just a second here. And then you get a nice bright one to finish it off. There it is. See, there's the front of the cargo bay. And we're back here on the right-hand side. So that's where the camera is. And now we'll go through it again, the main part, a couple times. Here's the main object coming up. Watch this one this time. This one shoots up, but watch this one react to the flash. And it's going to come up like that, very sharply. Getting close to the flash. Flash, and there it goes. Streak. Second streak. Can we see it? There's a second streak coming up there. Hard to see, but it's there. And here's the fast one. Here's the slow one. And we will look at these in computer enhancement in just a second. But we'll watch this one more time. Here we go. Same thing again. There's number 2. And here's this one over here. You might kind of keep your eye. Here comes the main one. Here's the slow. You'll see the fast come in and shoot up. And the main one will streak out again. There's the slow. And the fast is going to, here it comes, a little tiny squirt coming in there. Flash, and up it goes. Like that. Here comes the second streak along here. Yeah. And now we'll see a computer enhancement of just this side. And we'll notice some funny characteristics. So kind of the beeping on the right-hand side, there's a continuous beeping, or the light is pulsing, see? That is the slow object. Here comes the fast one. It really doesn't beep. It's going to come in. That's beeping and that's beeping. Here it comes, and flash, and up it goes. And this one is going up. These are the 2 that are following up also. This one also, notice, has that little pulsing light on the right-hand side. They're not tumbling. They're not tumbling like ice particles would. They're just going straight up.
Very controlled.
That's right.
Yeah.
And now we'll see the main object after this See, they're tracking right up there. These would be two objects that would be interesting. But see that there?
Yeah, just a regular pulse.
Yeah. And ice particles should be tumbling.
And they wouldn't be pulsing, would they?
No, no. Here comes the main one. This is just a computer enhancement up close. There's the lower atmosphere, and over it comes and shoots out like that. You see the flash? There it goes, and then out it goes. There goes the streak. Right through there. And it's clear out here.
It looks like those other ones are scouting over to check on what happened.
Yeah, and these all came in that direction.
And that one there to wait
Yeah,
for left.
this one's coming up too. See, here they come. And that's the fast one following up, and that's pretty much it. Yeah, I think it's important to realize that there were 4 NASA scientists that were asked to look at this tape and to render their judgment on it. And I think it's important to realize that they probably did their job and did it very well. They were probably pulled off their regular routine and asked just to look at it and just to look at the film. They weren't asked to do any scientific analysis of it, frame by frame or anything like that, like I have done, but just to look at it and to come up with a plausible explanation. And they did that, and they did it well. And from their point of view, to the depth that they analyzed it, I can see why they would think what they did. And if you analyze it further and with more depth, I think that you can see that it doesn't really hold up very well. I think we should look at this as being not us against NASA or anything like that. I would hope that NASA scientists would be interested in this, and we're all just kind of members of planet Earth that are trying to figure out what was going on here, and any scientist worth his salt should be willing to examine it in greater depth, and that's what I've tried to do.
Okay. Let's look at the shuttle then, and you can explain, where is the camera mounted?
Well, the whole thing, yeah, the whole picture. Here's the shuttle, and here's the cargo bay, and these doors open, of course. And there were several locations that the camera could have been on. One of them is in the middle of the shuttle here, and one of them is on the arm that extends up, and there's one in the front also, but there's also one in the back. And this is where it was. It was about right here on this side of the back, and it was pointing up more or less in this direction, pointing up like this. And so if that's dead center, and the object that you saw in the film is over here, so if they're ice particles, they're just kind of flying around up here somewhere, if they are ice particles. The ones on the right would be over here a little bit more. But the whole general area is up on this side of the shuttle, up in the air, something like that.
Close to the shuttle?
Yeah, it would be.
If it were ice particles.
Well, if they are ice particles, then I've calculated that they would be about 95 feet up from the attitude adjuster rocket, something like that. So that would put them, the shuttle itself, this is about 17 feet wide from one side to the other, so 95 feet's about over here somewhere. And so if they are ice particles, the main one now, it would be over here someplace, something like that. Now we need to keep that in mind when we talk about which attitude adjuster rockets might have pushed it, because it goes off like that. And so obviously these are out because the front ones couldn't possibly have done it. And then our other options are, there are some attitude adjuster rockets right here on this side, and same thing over on this side. And I think it's reasonable to assume that they have to be here because the objects are up here, and the main one goes up like this. And so it's this group here that has to do it.
Okay, and are they positioned to eject out towards the direction that the particles move?
Not very well.
Because they look like they're aimed back.
Well, some of them are, and some of them, they go in all different directions.
So
these 3 go up like this, and several go over, some go back, and some go down. So there's several different ones. I have been able...
these 3 jet ports, are these jet ports?
Yeah.
To the top there?
Yeah.
So they eject straight up?
That's right.
Okay.
Now, I have been able... There are 2 kinds of attitude adjuster rockets that the shuttle has. Regular rockets and then vernier rockets, which are much less strong. The regular rockets have a thrust of about 870 pounds, and the verniers have a thrust of about 24 pounds. When the regular rockets go off, any one of those regular rockets, the shuttle itself will react by turning one way or the other. And that's what they are designed to do.
That's what you mean by attitude adjustment.
That's right, yeah. The attitude adjustment, if we close this up now, to show you a little bit more specifically, the rockets are designed, depending on which ones fire, to make it do this, or to do this, or to do this,
Right.
to change its attitude or its orientation in space. Now, I have figures that James Oberg supplied to me about the degree of rotation or the angular acceleration that is produced by all the attitude adjuster rockets. And it turns out, just to give you a little bit more background, there are 38 main strength rockets and 6 verniers. There are 14 and 2 up here. We've already ruled this out. But on either side there are 12 main and 2 verniers, here and here. And I know the directions that those fire, but if you take the acceleration produced by the main attitude adjuster rockets and realize that the film goes for 65 seconds after the object shoots up, then you can calculate how much the picture should have rotated. And it turns out that it would have rotated about 6 degrees. And that would be clearly visible in the picture that the shuttle has. And since there is no rotation in the picture, that rules out those 24 main rockets and leaves only 2 verniers here and 2 verniers here. I need to show you a picture to show you how much the picture would change because of that rotation. Let me get it out for you. Now, this is a simplified diagram without all the extraneous ones. Here's our main object coming over, and there's the flash, and it shoots up like this. And here's number 2 that we talked about, coming up and shooting up like this. This is the top of the air glow. The horizon is down here, but what you really see that looks like the horizon in the picture is really the top of the air glow, and that's where that is.
Atmosphere?
Yeah, that's right. That's equivalently what it is. And I'll show you now another diagram. This is what you actually have, and this is what you see through the entire 65 seconds after it shoots up. This is where the air glow would have been if it had been one of the main attitude adjuster rockets. It would have shifted from here over to here, and it clearly does not do that. And so
why would it shift, I guess?
Because if we can shift over to the shuttle here, let's say that this attitude adjuster rocket fires in this direction, that's going to rotate the shuttle like this.
Oh, okay.
And so the camera goes. That's right. And so you can calculate how much that would have been. I mentioned it was 6 degrees. 6 degrees would be just this much.
Right.
And that's obviously noticeable, and it doesn't happen. So that enables us to eliminate 38 rockets that are possible at once. And we only have the 6 verniers left. So that really simplifies things. And so now we can go back and take a look at the shuttle and see what other possibilities we have.
Okay.
And so let's do that.
Okay.
We've eliminated the front. Now, we've eliminated the main rocket, so let's really kill these front verniers.
Okay.
The front verniers, there's one of them down. It exhausts down and a little bit to the front like that. And it's really difficult to imagine how a rocket like that firing could do anything back here. So the nose goes, and I don't think anybody would give me any static about that. The other possibilities, remember, we're over here. The particles, if they're particles, are over here. One of the vernier rockets is here, exhausting in this direction.
Okay.
And another is underneath, exhausting down. And I think it's fairly obvious that those couldn't possibly reach over here either, so we eliminate those 2. And that leaves, on this side, one that shoots down. Hard to imagine how that could get up here. And then the only one of the 44 that really has any chance whatsoever is the other vernier here that shoots out in this direction, like this. So, that's ballpark feasible, I guess. So in all that follows the rest of the analysis, we've got to think in terms of the one vernier rocket here firing directly out in that direction, and that's the only one really that could be fooling around with these things up here in any fashion at all.
Could affect anything within a short range of the craft.
That's right, yeah. And that immediately raises some questions. These are not conclusive proofs, but the rocket fires directly out like this. NASA designs their rockets so that you have what's called purely laminar flow straight out from the exhaust, and that's the way they should be designed because that's the most efficient to get the thrust that you want. But what that means is it's like a cigarette. You put a cigarette in an ashtray and you let it sit there. The smoke just beautifully comes up like this if there's no air in the room, and then maybe swirls around on top. Now that's an oversimplification because what you really have here is laminar flow, right, coming out like the cigarette, but you have a very hot gas which is expanding as it goes out. And so we really can't just absolutely say that there's no way that this exhaust could reach up here. We can't just outright dismiss it. As a matter of fact, where the plume goes is a very difficult problem in gas dynamics, and NASA engineers have a tough problem with it too. And so it's kind of an unknown area, some parts of it. So I guess we would say, well, I suppose if you have this, we could assume maybe it's going to spread enough to get up here and push it up. To me, it's stretching it a little bit, but yeah. It's not enough really to kill the ice particle theory, I don't think.
Okay.
Yeah, let me explain a little bit how you can get all three velocity components, left and right, up and down, and in and out, from a flat TV screen. If you want to imagine that we're on top looking down at the camera, and say the camera's right there, and the camera's pointing in this direction, we'll say, then the middle of the camera picture is along that line. And as you look in the camera, let's draw a line. See, that's where the flat TV screen would be. And as you look in this direction, left and right really is left and right on the screen. But look what happens, and this is the key idea. Look what happens when you look over here on the screen, the picture that's being taken. You look out in this direction, and left and right becomes like that. And notice that left and right now includes some of the in and out, the third dimension. And so consequently, that information is captured on the film. And so if there is a way to get that information from the film and quantify it, then you can get the in and out, left and right, and up and down motion. Now I could draw the same picture from the side, but it's the same type of argument, so we can just let it go at this. The point is, even though you've got a flat screen, because left and right at this angle goes into the in and out, that information is contained in the film. And so you can get all three dimensions from it.
Oh, okay.
In